Low-cost PC-based mixed-signal oscilloscope for academic application using C2000 microcontroller is our project. This is a list of components that has been used in the product development. This consists of both the TI parts and non-TI parts that has been used. All the components are listed in the tabular column. Low-cost PC-based mixed-signal oscilloscope using Texas Instruments microcontroller TMS320F28027 is our project. This is the experimental setup that has been designed, and the C2000 microcontroller is kept out for convenient connection purposes. The experimental setup consists of current sensor and voltage transformer for sensing the voltage and current that has to be measured. And it also contains the signal conditioning board that converts the bipolar signals to unipolar signals for measuring, and it also eliminates the noise signals. The supply voltage that has to be measured is given through an auto transformer, and we have used a lamp load for which the current is to be measured. The voltage and the current waveform is obtained in the DSO for validation. We have developed the standalone GUI, that is graphical user interface, with 4 analog channels which can display the analog signals with the help of C2000 microcontroller. The sampling frequency and the time per division is also displayed in the GUI. Thus, the current and the voltage waveforms are obtained in the standalone GUI using C2000 microcontroller. On varying the sampling frequency values such as 1000, 5000, the corresponding graph is obtained along with the time per division displayed in the screen. Thus, the analog signal can be measured using C2000 microcontroller and the standalone GUI that has been developed. Similarly, we can display the digital signals in the standalone GUI, that is graphical user interface, interfaced with the C2000 microcontroller. For example, we have generated a 1 kHz pulse and validated it in the DSO. We have developed a standalone GUI for 4 digital channels which can display 4 digital signals. This 1 kHz pulse which is generated is given to the C2000 microcontroller, interfaced with the GUI in the personal computer, and the graph is verified by changing the sampling frequency as 10 kHz, 100 kHz, and so on, and the waveform is verified. And the time per division is also displayed in the screen. Similarly, a pulse of 2 kHz is generated, and it is also validated in the DSO, and this pulse is given to the C2000 microcontroller, interfaced with the standalone GUI in the personal computer, and the sampling frequency is kept as 10 kHz, and the waveform is verified. The sampling frequency is then changed to 100 kHz, and the waveform is verified in the standalone GUI in the personal computer. And thus, similarly, the sampling frequencies can be changed and varying graphs can be obtained. Now the duty cycle is changed to 0.3, and the waveform is verified in the standalone GUI by varying the sampling frequencies. Initially, the sampling frequency is kept as 10 kHz, and the waveform is verified. And now the sampling frequency has changed to 100 kHz, and again the waveform has been verified.
Good evening. I'm Dr. Kalyan Kaur, working as a professor in the TPD department. I've just gone through the low-cost PC-based mixed signal oscilloscope developed by our pioneer TPD students. It was very fantastic and a very amazing initiative, and very cost effective. I just gone through the demonstration, and the results were quite encouraging and very positive. However, certain small limitations I just observed. That is some of the analog noise signals which has got scope for improvement in the signal design as well as the size could also be made compact. These are the two limitations I have seen. There is a vast scope for improvement. The development was very much encouraging and very affordable for the students' community as well as for the institution. I just wish them good luck for the future design improvement and for successful growth in the oscilloscope.